Wait, that's familiar. Let's go over here and start the slideshow. Okay, so Tony and I have like kind of two pieces that we want to talk about. The first one is service workers and offline support for websites. And the other one is more like the history of the web and why we arrived at Remix, or why I am personally excited about Remix. What problem does it solve? Why do we need all of this JavaScript? So let's start. I already did the introductions. Tony and I are both excited about web development. We both live in California, and we both meet every Monday and talk about all things web in like a small meetup that we, guess at this point, kind of both organize. Yeah. So let's start with a little story about the web. Most of you have said they are full stack web developers. So you are familiar with HTML, CSS, JavaScript, right? This is the front end guild, which makes a website, which runs in a browser, which is what we call the client. And then we have the server, right? This is somewhere in the internet, somewhere else, we have the web server running. Cool. So we also have to think about the protocol between these two, right? There's the internet or the web on top of the internet. And we mostly think about HTTP, where we have HTTP cookies and caching headers and all that good stuff, right? So, and then our server, maybe it's a Go server or a Java server, or it's a JavaScript server. It may also be connected with a data storage, right? So we can persist user data, and session data, and what everything we want to have like a dynamic experience. So as a web developer, we by default or natively have to operate on the client server model, right? We have to think about the native experience on the browser. We have to know the browser API, styling, HTML, and JavaScript. But we also kind of have to be aware that there is a server, even if we only configure it to serve static files, or maybe we even implement it because it's we do server-side rendering. We have to know the protocol between it, and even maybe something like the data persistence behind it. So congratulations, we're all full stack developers, even if we work with old school web dev, PHP 5 and JavaScript, HTML, CSS, we're already working full stack, right? But the native apps came along like iOS and Android, and you download them once, they run on your device, and every view transition is instant, right? Like it's super snappy, you have these sweet animations. And we web developers were like, that's kind of cool, we also want this. And that's why we rephrased or like rebranded us from website developers to web app builders, I guess. And we wanted to have this like native look and feel, right? We want quick transitions between different pages. We want not this like multi-page application. We want a single application, right? Single page application. And that's why we started moving more of our logic, business logic, to the client, doing client-side navigations, focusing on animations. And offline first is also something that first came up, right? Like, I guess this all started already like 10, 15 years ago. But yeah, this is this kind of trend, right? And you also have to think about the fact that the browser have evolved a lot over that time. So back then, browsers were kind of all over the place and very different. We had Internet Explorer still around. And there was this need for a lot of JavaScript, or people thought there was this need for a lot of JavaScript to kind of make up for this, right? And like enhance. Cool. So we still have the client-server model though. But we now started to move more and more stuff to the client. So stuff like Webpack came around, TypeScript, React, right? Since we do client-side applications now that are very client-heavy with a lot of business logic on the client, we need more tools to like scale that, right? That's why TypeScript is important. We want to use features that the browser doesn't support yet. So maybe we have to bundle it like Webpack, right? JSX, the templating language that React uses, is nothing the browser understands. So we need a bundling compiler for that as well. And then, since there are no iOS and Android apps, and most companies say they have to support all of these different clients, right? The website or the browser, Android and iOS, there might be more clients that have to be supported by the same business logic or server, right? That's why something like REST or GraphQL is very interesting, because it's very generic. It's not just to serve the website, it can serve all other clients as well. So now we have this move that, okay, the server is not only a web server anymore, but like a very generic server. We usually say REST server, right? That can serve all the different clients. Maybe you even have like a third-party API endpoint, right? Like you can even serve people and integrate their applications. And everything comes a little bit decoupled. What's painful though is if you only build a website. So I'm only a web developer, I don't care about iOS and Android, is now that I have to kind of, if I want to use the same technologies that everybody else uses, I kind of have these two applications now, right? I have the REST server, it's its own project, its own like terminologies and logic, maybe different language, right? Maybe I write this in Java or Go. And then I have my web app that is maybe all statically served through the CDN, but it's its own application. And now it's maybe 2 Git repositories. Maybe that's what we had like 5 or 8 years ago, right? I had like the web version and then the backend or API repository just for one project. And that's kind of painful. It is good. It feels a little native, but yeah, we can do better than that, right? I think this is also where the term like front-end engineers started to come up, right? Like you focus heavily. I'm a React developer, right? I'm not a web dev anymore. I'm a React dev, so I'm doing front-end engineering. And that obviously also came with the fact that the complexity is growing and growing and growing, right? Like apps like LinkedIn are massive, and it's all front-end code that has to be maintained. Cool. But it turns out that rendering JavaScript only on the client and not like doing any kind of server-side rendering has some downsides. SEO is one of the things that you hear a lot, but it also obviously if you try to do everything on the client and have no server, you also kind of neglect one of the two pieces of the client server model. So HTTP caching or like cookies is nothing you can use anymore. It's like security concerns also if you want to connect to your database from the client, right? Like if you don't have access to a web server, you have to jump over a lot of hoops to achieve the same kind of stuff. So that's why folks were like, okay, maybe we need a web server. Maybe we can't just use the CDN for everything. That's maybe like 5 or 4 years ago when Gatsby and Next.js first came along, probably a little longer even. And we started to do both again. So we have some kind of rendering, maybe it's during the build step, but yeah, there is some kind of server step involved again. But it's still painful because even if the REST server and the web server are kind of the same server, you still have this huge divide through the fact that we have to operate on the client server model, right? We still have to communicate to the server over the internet. And when every time you want to have some data, you have to make another REST fetch, you get JSON data back, then you have to interpret that to render some more HTML. You have thousands of loading spinners. Yeah, it's just a lot of complexity that we have to handle with this model. So it's still kind of 2 code bases mostly, even though maybe they are maintained from the same front-end team. And even if you manage to get them in the same project, it's just not perfect there yet. We don't have the types from our back-end endpoints and our front end, right? Like there's something missing. It's not very productive. And that's kind of where the full stack web frameworks start to get in, right? Like something like Solid Start or Next.js or Remix and SpotKit that kind of take a more holistic approach in the sense that they output 2 bundles. One that you would serve to the website and one that runs on your server. So now you have one project, one Git repository, one language, JavaScript, that you use for both the client and the server applications of your website. So you could say we went full circle if you maybe started working with PHP and you always did server-side rendering and dynamic stuff, and then you look at Remix, you're like, we have been here. This is nothing. A lot of the concepts, right? Like Remix is all about like, we take advantage of HTTP caching, and there's like people who build with PHP are like, and what? Why are you excited about this? But yeah, so there's definitely some like nuances that make Remix introduce some new concepts, even though the baseline is obviously just web standards. And that is stuff like the way Remix progressively enhances the experience with JavaScript, right? You still use React on the client. So once your application hydrates, you still have a React application running. You have composability with React. But then you still have, you now also have the communication with the web server, and that tightly integrated. So you write server code and client code in the same files, and Remix understands to split that into 2 bundles. And that's something kind of newish, or like SwellKit and stuff also have that, but that's what these full stack web frameworks have kind of what makes them new, so to say. Cool. So now we have one code base where we can infer types from our backend endpoints and have them in our client application. We don't have to have that much context switching because we can work on the same files, or at least in the same project, and we have to duplicate less code. Cool. One thing though that is still not native is offline support, right? Like if I were to switch off the internet on my Remix application, I would still get the Chrome dinosaur because we don't have offline support. But that's where service workers come in.
Andre? All right, so I guess before I start, I wanted to ask who here has worked with service workers before? Oh, just one person. Okay.
Nice. Perfect audience.
Yeah. All right. So I made these slides super basic, so it'll be perfect. All right. So I'm going to introduce to you guys service workers and how they'll enable us to make apps work offline. All right. So I'm starting very basic here. On our, I guess it's your left, we have our browser. And then in our browser, obviously, we have the DOM with our HTML. And right here, I put that it's being controlled by our app.js script. So that's basically just our main JavaScript file that is running that page. And then, of course, on the right, we have our server. So as we all know, in a standard web application, what happens is when we send a request to the server, we get back a response, right? So very simple. But what happens if the server is offline? We're going to send requests, but obviously the server can't respond, so our app just stops working. So how do we solve this problem? So that's where service workers come in. So service workers are basically just a JavaScript file, except it is separate from your main app.js file. It runs in the background on a separate thread from the main JavaScript file. So it's two different threads, and it comes with some benefits, right? So because it's on a separate thread, it's non-blocking. So you can do processing whatever you want in the service worker file without blocking the main thread. And at the same time, that also means the service worker won't have any access to the DOM directly. So if you wanted to do something that actually affects the DOM, you have to pass messages back and forth between your app.js file and your service worker file. Okay, so when we send a request now, and if we have a service worker, one of the features of a service worker is that it can intercept all fetch requests. So whenever you make a fetch request, it actually goes to the service worker first. And in the service worker, you can do anything you want to do with that request, including just sending it right through towards the server. And of course, if you send your request to the server, you're going to get a response back. And again, this response is going to get intercepted by the service worker. And you can do anything you want here, including, of course, sending it right back to the browser or to your main app. So in a sense, the service worker just acts as a proxy server that sits in between your main JavaScript and the server. Okay. And I guess another thing to note is service workers, they don't have to just be something that's taking requests from your main app. Service workers can actually send requests directly from a service worker to the server and get back responses. Okay, so how does all this help with making your app actually work offline? Like when we send requests, if it goes to the service worker, it goes to the server, nothing's going to happen still because there's no response. So what do we do? So the answer to that is another feature that comes with service workers, and that is the ability to cache assets. So in a service worker, let's say when you send a request to the server and you get back a response, that response can be cached. So what that means is if you get back HTML, JavaScript, CSS, images, audio files, whatever response you get back, you can add that into a cache. And then that cache can later be used to actually make the app work offline. So let's put all this together, and I'll show you guys how this will actually enable us to make an offline app. So here I'm going to start from scratch. We just have our browser, main JavaScript, and then the service worker, and then our server. Let's say our app makes a request. It goes to the server sends back a response. That response is then cached and then returned to the browser. Now, let's turn off the server, and then we'll make a request again. So now this time, the request goes to the service worker. The service worker will know that the server is offline, and it can do that by sending a fetch request to the server, and it's gonna not get back 200 response. So it'll know that the server is offline. And so then what it's going to do is look into the cache and see if it has an answer for the request. And if it does, it just sends back the response. And there you have it. We now have an app that works offline because in a sense, our server is actually the service worker. And of course, things can get a lot more complicated than this, right? Because let's say, we have dynamic data and everything we cache was, just static files, right? So we had to deal with that. So this is just a very, very basic example for, let's say we had a static website, but things can definitely get way more complex. And there's solutions to all that that we can get into as well later. But at the end of the day, this is the minimum example of how to make an app work offline. All right, so in this next part, Andre and I were thinking of giving a live demo where we actually show you guys how we're gonna add offline support to a Remix app. So we're gonna spin everything up from scratch. Hopefully we don't mess up and everything works.
Messing up would even be more fun. Okay.
And I guess as we go through this, feel free to ask questions because I know you guys had a lot of questions about Remix. So, we can just kind of go over that at the same time as well.
Yeah. Just please interrupt us.
Yeah.
Please. Okay, so let's start by creating a new Remix project.
Yeah.
Yes.
Go for it.
What's the bandwidth, what's the throughput between the service worker and the non-thread? Like, since you hear more reactions back and forth, is there a important consideration here for how much stuff can be back and forth?
I'm actually not sure if there's a limit, so I don't have an answer for that, unfortunately. But I'll look it up after this, and I'll let you know.
I guess like a 10,000 volts, okay, what are the major concerns there? And I know that there's still trying to stuff much stuff for this.
I actually haven't hit any limits yet, but I don't think I've built anything that's significant to run into the limits. Because usually the only thing I've done between a service worker and my main JavaScript app is sending messages, and those messages are pretty small, right? So you just send the message and then maybe a small payload with some data that it needs to process that. And so far my payloads are super small, so I can't tell you if there was actually an upper limit somewhere.
I'm thought over here. So service worker is native to the browser, right?
Yes.
It is a feature of the browser. So I think that's pretty important, right? So if the browser itself is running separately, the browser will manage the
yeah, but there's no shared memory model. Your shared memory model is like a small
correct. Memory that would be copied yeah.
Well, it's sort of the place, the browser can set up, the JavaScript can set up in that place, the question about how much stuff is there, then pass that.
I feel like there's probably a limit because, for example, local storage, you have 5 megabytes, I think. So there probably is some limit, but I'm not aware of that.
Yeah. Your browser also, every time you visit a website, kind of caches the static files in disk anyways, right? If you go back and forth on the same website, all the images are cached. So I have a gut feeling that a service worker's cache would end up there in that kind of area. So it's probably more unlimited. Yeah.
Or the stuff has to pass through the memory area.
Yeah. Yeah.
Those are I think your point of bandwidth, the throughput, your point of streaming it, and everything has to go through the proxy,
We all have our phones. If someone of you wants to ask ChatGPT real quick, we have an answer.
All right.
Okay. So first step is creating a new Remix app. They have a CLI for this, so I just run this CLI. There is a command to -- template. You can select the underlying server you want to use. I'm just going to use the default server, which is an kind of hidden away Express server, I think, or at least it runs a node. call the folder Hacker Demo. I want to initialize a Git repository, sure, and I definitely want to install the dependencies. I hope the Wi-Fi is fast enough for that.
No, we switched to a hotspot.
Okay, it's I did that earlier, so I hope most of the stuff is going to be cached.
Can you change that output to be if it's yarn or PM or something else?
Yeah, for sure. The CLI doesn't give you an option to select if you want to use yarn or npm, but it's basically just a boilerplate app for a node project, so you can do whatever you want with it. Okay, so that was done. So we will go there. So since I don't have any Figma designs, I guess I have to start from scratch, and I can't use a cool tool here, but let's start by investigating the folder structure and by running the dev server. Okay, so we have an app folder, very common, and we have a public folder, also very common. So there is a server.js file somewhere hidden here, and I think I could make it visible. In all other adapters, or if you would start a Remix app from scratch, basically just creating your own file structure, you would just have a bun server, a Cloudflare server, a node server, something running, and then Remix uses an adapter to just work as a request handler on top. That's how Remix operates on top of so many different servers. But ours is hidden. So everything you see in the app folder is part of your Remix app, and it's either going to end up in the server bundle or in the client bundle. And the client bundle is all the static files, the JavaScript not the HTML, I guess, because that server side rendered, but all the JavaScript that is going to be served over the internet. And that is going to end up in the public folder. So the public folder is just how you would expect it if you build your own node or Express server, right? Like this is the source of your static files. And if you look inside here, this is all your client build. And you see there's like this entry.client, like a manifest file with all, so Remix knows all the different routes you define and all that stuff. And then the bundle for the route.js file and whatnot. Cool. So if you go back to the app folder, you see there is almost nothing here. There's a root file, which is the root of our application. It looks very similar to any other root of any other React app where you have an app component. One interesting piece with Remix is that you have the full HTML document in here, which is kind of neat because you can dynamically render any meta things in your header. And you also have this like meta and links components to inject links and meta text in a very nice way. So I'm going to create a routes folder now. Oh, it already exists. I'm just not seeing it. It is down here. Okay. So this is our index file. This is Remix has file-based routing structure. You can create your own very easily if you just go to the Remix config file and configure your own. But the default one is going to be in the routes folder. You can have a nested routing structure. So if you go to the link down here for the dev server, this is what the root app and then the index file or the index route looks like. And I think you want to create a second route now, right?
Yep, yeah. So what we're going to do first is we're going to make a simple 2-page web app. So basically just a home page, and then we're going to make a second route just so that we can show you guys we have a web app that works, and then it's not going to work offline. So we have a baseline, and then we're going to make it work offline. So right here, what Andre is doing is he's creating another file in the routes folder. This is called page2.tsx. And whatever the name of the file is, that's also going to be the URL path. So very similar to a lot of other frameworks out there. And we're just returning a React component from this file, which will render out the HTML that shows up on that page. So super simple.
Yeah, it's also doing
Yep. So we're just gonna link to that page.
I have a German keyboard layout here, and I'm never using it, and I'm struggling really hard right now.
Yeah, get some commentary in between is, so right now we're using a standard A tag to link between the first page and the second page. And that would work just like as you expect in any other, HTML file. But Remix does also have So let me step back 1 second. When you use an A tag and you do a navigation, you can do a full page navigation. So that's what I'm trying to say. And Remix also has a link component that we can use. I'm not sure we want to do that now, so
Yeah.
you want to edit it? Okay. All right.
There's a difference for basically browser navigation versus client-side navigation.
Yes, correct.
Yeah.
Yeah, exactly. So
You can do both.
you can do both.
Also, if you would disable JavaScript on the client and you have the link component, it's also just an anchor tag. Yeah, progressive enhanced.
Yep.
But we're going to keep an anchor tag for this demo so that the service worker stuff is going to be easier.
Yeah, there's a workaround you have to do if you use link tags. So if you guys are really interested, when we're all done, we can go back and do it, right?
Yeah.
But anyways, so now we should have 2 routes. So right now we have our super simple website with our homepage here. And we're going to turn it offline. And dinosaur.
Why is it not native?
All right.
So how can we fix this?
Yes. So as mentioned in the slides, first thing we need to do is add in a service worker. So where do we add the service worker? We're adding it right now in the public folder. So one thing to know about service workers is where you locate them is actually very important. So let's say you have a site called example.com. You want to have your service worker available at the root of that website. So example.com/service worker. So your service worker file could be named anything. Right here, we're just calling it sw.js, but that name is completely up to you. You can call it whatever you want. The only important thing is where it's located. And the reason for that is if you have it at the root, your service worker's scope is going to be your entire site. Whereas if you had it like at a subroot somewhere, your service worker can only control things in that subroot and down.
Yes.
The browser or the service worker specification.
Yeah, that's a service worker specification. Yep.
So everything we're going to do in the service worker file is not associated with Remix, basically. Remix doesn't have a concept of service workers.
And
I wouldn't know how to share it easily, but I can invite you if you're interested to we can share the recording later of why you're interested. Is it hard to read? Okay, let me just zoom it in a little bit. Is this okay? Okay, no, please. Yeah. Want it to be visible. Okay.
there's up here too.
Yeah.
Yes.
There's actually this one right here, we really front row here.
Yeah, and just quickly for anyone who's coming in late, we have food in the back, so feel free to grab some pizza or donuts or whatever.
Okay, so I have a JavaScript file in my public folder now. I can obviously go online again and just serve it because it's my public folder, so it's accessible over the internet. But this is not how I'm going to run it, right?
Of course. So now that the service worker is in the right place, we actually have to register it. So to register a service worker, you want to write a little code somewhere that in your app. So in this case, we have a Remix app. So a good place to do it is in the entry.client file. So basically, this is the entry point to the app on the client side. So this is the first thing that will run on your client.
Yeah.
And this is a perfect place to register a service worker. So to do that, we're going to first listen to the window load event. So we know once things have been loaded. And also another thing we should do, I always forget this, is we should first check to see whether or not there is support for service workers. So service workers, they're actually supported in all modern browsers. So you shouldn't have any issues using service workers, right? It's good practice to always check. Let's say, you actually are supporting IE, like Internet Explorer still, then yeah, you might have to check whether or not there is support. So right here, we're checking to see whether or not the service worker property is in the navigator object. And then if it is, we're going to register the service worker, and Copilot is trying to give us some wrong answers here. Okay.
Yes.
So what we're simply doing is we're calling navigator.serviceWorker.register, and then we're passing it path to wherever we place our service worker. Okay. So now that we have that piece of code in, so if you guys use Chrome, you can go to Chrome DevTools, and then there is the application tab, and there is a service worker tab. And you can see that our service worker is now activated and running, which means our service worker is working. And since we added in a console log statement in our service worker, we can see it in the console here. So anything you console log in a service worker will be available in your normal console.
Cool.
Okay, so that's step one.
So we have a fully static app right now, right? We don't make any requests. How can we make this fully static app offline?
Yeah. So as I mentioned before, we have to cache some assets, right, in order to be able to serve it when it's offline. So in the service worker, they're similar to our main JavaScript file where it's event-based. So like, for example, on your main JavaScript app, you can do like window add event listener to like a quick event or something. In service workers, you have other events that you can listen to. For example, you can listen to install events to see when the service worker has been installed, and then activate, which is after it's installed, it has to be activated before it actually takes control of your web app. Some other ones that will be relevant to us is the fetch event, which basically says whenever there's a fetch event, intercept that fetch event and do something with it. So those are probably the important ones. There are definitely more events you can listen to in a service worker, but I think those were the relevant ones for us for this. Okay, so I can just adding in our event listeners.
Okay. So since I made changes now to the service worker, right? What's happening with the we have the old one installed. So how do we go from here?
Yeah, so when we have service workers, so I have to reload the page. And whenever you make a new request to the server and there's a new service worker file, that service worker file will automatically be downloaded to the browser, and it's going to install, but not activate yet. So the reason for that is because let's say you already have a service worker that's installed, right? You don't want to just kill that service worker immediately because let's say it's doing some processing, right? You don't want it to just interrupt that. So you want to be able to control when that service worker actually takes over. So that's why we have the activate event. So right here, when we're developing, a quick way to do it is just to either click the skip waiting, or at the very top, there's a checkbox that says update on reload. You click that. Yeah, so that just automatically will, every single time there's a new service worker, we don't have to manually go in and click skip waiting. Obviously, when this is like a production app and you can't, tell your users to go and click that button, right? So there is actually a way to detect when there's a new service worker being installed, and we can basically listen for that event and then prompt the user to update. So basically, we can prompt the user, hey, there's a new update, would you like to update? And if they confirm, then we programmatically do the skip waiting in the service worker. But yeah,
You could have multiple services, correct?
I think so. I have never used.
Well, I'm assuming there's some unique identifiers associated with each of them, right? I mean, is it one of those where you can actually, just like you mentioned event listeners, where you can say, well, here's the active listening system, where you can actually view those and individually cancel them or run them or anything like that?
So I know you can, as far as I know, you can only have one active service worker run controlling a page at the same time. But you can have multiple service workers, as you can see here. We have two right now, right? One that's actually active and one that is waiting to be activated. I think you can have even more controlling different pages at different scopes, but don't call me on that one yet. So yeah.
I mean, we can easily test it later. I don't want to screw anything up yet, but we can just add a new file, have a console log, and see what was happening. It would be a cool experiment.
Yeah.
Cool.
Okay.
Okay, so if I were a user and I would leave this page now, and then wait and come back, then this should trigger the activation of the new service worker, right?
Yeah, so besides, doing the skip waiting, the other thing that also would update a service worker is when the user closes their window, and it has to be every single tab. So if you have one tab still open, then the service worker will not be installed. Not like the new service worker will not be installed.
Not activated.
Yes, activated.
Is a service worker like shared across multiple tabs? Let's say the same.
Yes. Yeah.
It's only one run, even though let's say multiple tabs.
Yes, only that one script. That's what you're right. Yeah.
Cool.
Yeah.
So what we already see is that I reopened the page, the new service worker is activated, and then we have 13 fetch logs. So for 14 times that we end up here where the service worker was registering any kind of fetch from our page.
Yep.
So I guess on first load, if you first load your website and you don't have a service worker registered, these fetches would go past the service worker because the service worker is downloaded after the initial page load. But every time you come back later and there's a service worker ready for the page, you would register any network traffic from that website, right?
Correct. Yeah.
Including fetch requests that we do as
Yes.
this.fetch. Yeah.
Yes.
Okay.
Yeah.
Cool.
Yep.
So how do we cache?
Yes. All right. So to cache things, I guess maybe first step is we should make a name for our cache. So just make a variable top and call it whatever we want. So we want to have a name for our cache because let's say we caching stuff and then we have a new service worker later. We want to have a way to be able to delete or clear the old cache. So this is basically just a way of versioning our caches.
Mhm.
Okay.
Nice. Okay.
Right. And I guess another thing we should do is probably add the routes that we want to cache. So this is like, for example, we have our home page, which is like the slash route, and then we have our page 2, was it?
Yes.
Yeah. So this is just so we can tell the service worker what pages we want to cache.
Mhm.
And what we're going to do here is kind of like a 2-step process because what we want to do is number one, cache all the HTML that is returned from the server. And then the other thing we want to do is cache all the static assets, for example, JavaScript, and all that is built by Remix. Okay. So I think let's start off with caching the HTML pages first. That's like the simpler one. So one thing we can do whenever we activate a service worker is we can tell it to do whatever we want. And that's probably a good place to cache some assets. So in here, we can do event.
So that was the thing now where this is an event listener, and now we have to do event dot.
Wait until.
Mhm.
Yeah. So wait until it's an API in service workers, and it basically says wait until a promise has completed. So what you pass into a wait until has to be a promise, and it basically the service worker will wait for that promise to be resolved. So right here, we're basically going to use an async function to return a promise where we cache our assets. So we'll probably load everything for us. And basically, so what we're doing right here is first we're opening a cache. So the caches is a global that exists in a service worker file. Yep.
So look at this.
Yeah. Yep.
Mhm. So we have several caches in here, and by giving our cache a name, we can have one cache within the multiverse of caches. Okay.
Yeah. So we're just opening our cache name that we defined up top.
Mhm.
And then after we get that cache back, we're just going to add all of our assets, which we call resources to pre-cache, into our cache.
And that was really wild to me when I saw this the first time. You just give it an array of request info, which is what you would supply to your fetch request. And it just iterates through them and makes the fetch request and then saves them in the cache. So all we give it is like, oh yeah, these are the two things you have to like go and get us. And then it will automatically put this in the cache. Yeah.
Yeah.
No.
And also it doesn't like recursively, if the home page is loading some other aspect.
Yeah.
Good question though.
Good
I
question.
also was like, I was literally asking him that yesterday. It's like,
Yeah.
does it already?
Yeah,
That-
that would be really cool. Though.
Well, let's not be greedy here. I mean,
Yeah.
this is magic.
This is already pretty cool, yes.
So it's two questions, because I imagine there, you know, we're also missing there is just a specification for like request all these things and stuff.
Yeah, so this is, so what you pass in is request info, which is the same object that fetch supports. So I imagine you can pass in headers, whatever you want here, yeah.
Yeah. So right here, we're being simple and we're just literally doing,
Just
you know,
routes.
yeah, so we can get really fancy.
That's really cool though.
Right, so I think now that we have this, maybe we should show that it has been cached first before we go onto the caching.
You don't want to be more bold? No, let's test this.
Yeah,
Okay,
let's test it. Let's see. Let's see if we actually.
so we should have,
Let's check the cache down there first to see that. Right, so this is our cache, and it's fairly empty. Right.
yes. And then if you go back to service workers and maybe refresh this or something, or wait a little, it should waiting to activate. And this time we're going to do the quick route. Oh, and we already see this has been populated. So on activate was triggered, and we end up here, and we see we have two entries here for these two pages. So if I go offline now, where's my network? Okay.
Yep, and it still doesn't work.
Why is that?
And the reason for that, obviously, is all we did so far was we cached. We haven't actually made any logic to actually take care of requests and responses yet. So that's the next step, which is why we have this event
Let's
listener.
thought for a second it was going to work out. About that on my
That would have been amazing.
So every time the browser makes a fetch request on our domain, we end up here, and we can event dot
respond with. So again, respond with is another service worker only method on the event object, and it also takes a promise as well. So what we're gonna promise that results to a response. So we're gonna make a amazing function that returns a response. And what this function is going to do is two things. Whenever we get a fetch request, the first thing we're going to do is we're going to check whether or not we already have that asset cached. If we have it cached already, we're just going to return our cache response. And then number two is if that asset is not yet cached, we're going to go off to the server, fetch it, put it into our cache, and then we're going to return the response. And again, I'll try to help this out here.
yeah, but it didn't put it into the cache.
All right. So again, that first line up at the top is we are
Sorry.
so we're checking our, so actually, yeah, first line 31 right there. We're just opening our cache using the cache name that we specified before. Then we're checking to see whether or not we have that request in our cache. And if yes, we're gonna serve the cache response. And then now back to line 38. Let's say we don't have anything cached. We now just do a standard fetch request to the server. And then when we get that response back, we just open the cache and we put it in there as well.
But I mean, it seems like regardless we do it, right? Is that fair to say?
No, not on the.
Oh, it's gonna return statement.
Correct.
I mean, but potentially you could tweak this to, obviously, you could say, do both in the case if you want to do a password here, I guess.
Yes,
Yeah.
yeah, you could do that. So the logic, you can get, super custom depending on the use case and you want that.
Yeah. Also, right now, we would literally intercept and cache every request.
Yeah.
So if you fetch all the events on Meetup right now, that would also be cached. And the next time you want to fetch all events from Meetup, we would serve the cache. So you would never get like new dynamic data. So if you want to use this for like exclude dynamic data, you have to, be more restrictive. Like hey, only cache it if it's in our build, like /build, like it's our, or like only if it's JavaScript files. Like you have to be more fine grained sometimes. So like that kind of stuff.
Line 32,
Mhm.
matching by event dot request. Could it be given, or like does it match by the request object itself?
Yes.
Yes, which is so cool. It takes like cookies into account, like everything.
Yeah, so remember when we said the cache add all, it can remember take just the route as a string, or it can just take the request as a input.
And
Yeah,
it also figures out whether it's a new request, not the old object. So it does like not an object equals, but like a proper deep equals kind of thing.
I'm not sure how deep it goes actually. So
How is this like Chrome specific versus like, is this just a Chromium thing?
this is service worker expected. Yeah.
Okay, let me rephrase that. How universal is all these, is all the magic?
This is pretty universal across the modern browsers.
We are pretty well supported with like this is now the cache API of the service worker, but the whole service worker API has very good support already.
Yeah.
Oh, it's not shown here, but like for each of these you can check.
Yeah, so service workers as a base has great base support. There's definitely certain things, for example, push notifications that don't have as good of support. So you definitely should still check if you're going to do something with service workers. Not everything is supported, but everything right here, yes.
Yeah, so the one thing that I thought was cool and I would love to see the implementation is how they match the request, because I think that was really cool to see. But the other thing I want to highlight also is this one. We put it in the cache, but before we put in the cache, we actually clone like we get something back from the network, the response object, and then we clone it and put in the cache, and then the other version that isn't cloned, we return. Does anybody have an idea why we have to do that? Why do we clone it before we put it in the cache? I think it's really interesting.
References?
Yes. So a response can come in, but the response body may be streamed. And if you work with streams and that stuff and you consume it, you can only do that once. So the next time the cache would serve the same response, you have to have the news, like a new stream that you can consume. Yes, so you can also do this just when you get a fetch response back from fetch, you can also clone on that. Yeah, it's part of the Nice. Okay, so shall we try it?
Yeah, it's good.
I probably have to get online again so we can download the latest service worker, huh? Yeah. That's our application tab saying it's here. Okay. So we have a new service worker. So in our cache, we see the two HTML pages there. But since we have not done any other fetch requests, so like if I would go now to the other page on navigation, that's a Remix thing now, you would download the HTML file for the next page, and then also all the associated JavaScript, because Remix does bundle splitting. So every page has their own JavaScript. That works the same way on client-side navigation and server-side navigation, that on navigation, Remix fetches the other JavaScript files. So if I were to do the navigation now, it would also do the fetch request and add it to our cache. But let's not do that. Let's go offline first and just see if only caching the HTML file already does stuff. Are we offline? Well, yeah, it says it's served.
Yeah, that's actually from the service script.
Yeah, it's interesting. It's probably, my gut feeling is it's from the disk cache. So we were able to even fetch the JavaScript, which I wasn't expecting right now. I was expecting that the HTML would show, but it would show a bunch of errors for the JavaScript. But I assume it was already in the disk cache. Yes, and now it's also in the service worker. So there might be, we have to, that's just me suggesting things, but maybe if something's already in the disk cache and it goes from the service worker, maybe to the disk cache instead of the website in that case, and then we cached it now. I don't know. That's cool. Yeah, I'm gonna do that. So now we see in the cache that all the JavaScript is also in here. So if I go back to the other page, you would probably see even more stuff here. Yeah, one more JavaScript file was loaded now. And I assume from the disk cache. Okay, let's do this. I'm going to empty cache and hard reload. And now, since everything is in the cache, everything was served from the cache, right? Oh no, that was also empty cache.
You want to maybe clear everything and.
I mean, we're offline, right?
Yeah, we are offline, so it's
Yeah.
working. So, oh no. Oh no, it's because of the hard reload.
Does the hard reload not make me offline? Just want to make sure that we actually have an offline experience. Let me crash the server real quick and see what happens then.
It's all client side, right? You can patch the server.
Well, only we have things already patched.
So the server is actually down now. So if I refresh, all this stuff is still coming from the service worker, which is fine.
Calling off the server same as going on.
So I deleted the cache.
Yeah,
The server's dead. Let's see if we killed the page. Yes. Okay, so let me restart the server. Yeah, I was expecting for the JavaScript not that we are not able to cache the JavaScript. I don't know why that worked. On page 2, let's go to the application tab. Service worker is installed. And yes. So this is the case now, since the service worker is already installed in the browser. Even if the cache is dead, the next time we load the page, the service worker is already here, intercepting all the fetch requests. If you were a first-time user, that would be a little different, because you would first download the JavaScript, initiate the service worker, download the service worker. So there's a little difference. But yeah, so since we have the service worker already installed, you load the page, we have everything in the cache now.
You can see the homepage.
It's probably just awkwardly sorted. Oh, you're right. Where is it? So we have page 2 in here. All the build files.
Is it because we loaded it on Activate or something? We loaded the page 1 and page 2.
That's true. That means.
And then we activated it and then we deleted the cache. So the activation event has not fired.
Yeah.
So activation, yeah.
You're right.
So activation only happens once for every service worker, not for every page load.
Yes. Yeah.
Okay.
Yeah. Good catch. Thank you.
But now if you go to the other page, the fetch request to that page, also there's one for the HTML document. So now it's cached again. Here.
There it is.
Okay. Nice.
So can we turn off our server again? See what happens?
Sure. We do it with the command line this time. I'm tired of. Okay. Refresh immediately.
Now we have our offline image app.
Yeah. You see, even a hard reload doesn't kill the cache of the service worker. So even if I empty cache and hard reload, it comes like it still serves from that cache, which is pretty cool.
The one that you're clearing. Like why is that?
So the cache that is displayed up here is probably the actual disk cache of the browser, where the browser would cache, not the service worker now. So there's one edge case which I would love to test, but I'm not sure if we can figure out is what if the disk cache is empty, we are offline, and then we try to, can I just delete some stuff from here?
You can delete, yeah.
Nice. Okay, if I delete all the JavaScript bundles and all the stuff that, oh, can I not? No, okay. Well, stand by, guys. Any other questions while I try to delete these?
No, that was my one.
Yeah, apparently it doesn't work for some reason.
Also, fun fact, all these like bundled static files that are served from Remix, they all have the caching headers on that are really aggressive. They basically cache these files forever because they have a hash on the file name. So every time you have a new version of your app, so that's why they're probably very, yes. And since they have these aggressive caching headers, every time you load your Remix app once, basically the JavaScript is going to be on the browser forever. I think, what's the longest caching header? So I think it's a year, right? So the stuff is cached for a year.
So, for someone who's not that familiar with hacking, there's the hard drive, hard disk caching, and then what was this other one?
So every browser, every time you visit a website, caches all the static assets in general. And then you can direct the browser how to cache with HTTP caching headers. So you can have like different caching headers and like forbid the browser to cache or not. But by default, the browser, if you download an image once, it will have it in there for a little while. So that if you navigate to the same page again, it doesn't have to download it, but just keeps it in disk cache.
So like when you did the hard reload and clear path, it didn't clear this cache because it's like two separate things to path.
No, it does. It does clear the disk cache. So what you tell the browser, if you click up here and say empty cache and hard reload, just like delete everything from that website. But the service workers stayed there.
So why did the service workers stay there?
Because Chrome thought it's a good idea. I don't. So these buttons down here are.
They're not part of the specification, right?
Yeah. So like this is just Chrome decided that like this is what they want to delete here and not. Like it's probably these are more for devs, right?
Also part of them. It's just that it's determining intelligently which one is on the hard drive.
Yeah.
Maybe they can
Yeah.
add another menu item.
Yeah. Down here also and service worker. Yeah. So at the end of the day, everything the browser downloads and stores is on your disk, right? It's on your file system, on your computer. But obviously they're in different sections just for security reason, right? Like every website has their own cache, every website has their own local storage, and every service worker has their own cache. And this is like all in their little boxes. And then if you clear it up here, that's just a Chrome thing. They decide what they want to clear when you tell them to hard reload. And apparently they decided not to include the service worker cache for whatever reason.
So then to clear the service worker, you have to do what you just did and you focus deleting.
Yeah. So this is in the dev tabs, yeah.
So, you know the order of priority for the caches for the browser that you're using for resource? Is it like?
No, I'm nodding because I think that's a really good question. That's also why I'm like deleting all the build files right now, because what I think happened is we went offline and I was expecting that we weren't able to fetch the JavaScript files from our server because we were literally offline, but the service worker still cached them, which I think means the service worker, even if the browser just reaches for its own disk for the stuff you already cached, it goes through the service worker, if that makes sense. So everything goes through the service worker. And if it's already in the browser, obviously that will be served first. Yeah.
You can probably expand the other storages like local storage section, so we can see what is there. And it shouldn't be anything.
Yeah, that should
From somewhere, I think that you can.
Good answer. Memory cache, service worker cache.
Oh, look at this, by the way.
Push cache.
You have a storage quota.
Yeah, obviously, like that's the LRU cache, right? I mean, if you
Yeah.
it is stored forever until the memory limit is.
Yes. That's true. Okay, so our cache only has the stuff now that is cached during the activate step. And we are offline. So if I refresh this page now, so we did a hard reload, so it's not on the disk anymore. So the only thing that was cached is our HTML file, not the other stuff. So what I imagine now what happens is now we can't really test it anymore because we already cached everything. But I imagine that even if stuff is cached on the disk, on the browser, it goes through the service worker, which is kind of cool.
Yeah, I think you can see the log, right? Log,
Mhm.
So you try to when you do a reload or something, it should writing the cache and setting some cache.
Yeah. So what we can do now is we go online again. So a service worker is gonna fetch everything. I'm gonna delete it from the service worker cache one more time, but not from this cache. So I'm not going to do a hard reload. And if we're then able to download all the JavaScript from this, then we no, right. Yeah. Sorry, I'm having too much fun with this.
Heard some. I heard that service workers have certain programs from development, either
Yes.
for retiring outdated ones, but there's some sort of programs.
Yes.
Like the outline, what are some like they can sort of.
Yeah, I think the main thing really is what we're doing right here is caching, right? So the way we actually set up things right here is actually going to be pretty hard to update things because every single time we're making a request, we're serving from the cache is available. So what that means is if we have something new, like let's say we have a dynamic page, like let's say we have like a store, right? And then our pricing updates. We're never going to get the new pricing because we cache our HTML already. So that's basically probably the biggest footgun is that you get in that site that you can get stuck there. And again, when we have a new service worker and we send it to the client, it has to be activated. So there's that skip waiting thing that we keep pressing, right? And if we don't have logic for that to happen, then it might never happen because again, the only way that that happens is if the user closes all their tabs, and we can't, maybe a user just keeps their tabs open forever, right? So I think that's probably the biggest flip line is basically we over cache and the cache is just never cleared. And let's say we have a bug or something, right? And it just crashes our site. The user just might just see a dead screen like forever. Yeah, until they, go in, they clear all their storage, all their caches. Yeah, you might be stuck forever. Obviously, there are ways, you can add some guards in your script to prevent that, but that's definitely the biggest flip.
Assuming you don't assuming you don't overcache, you don't just like you one person or whatever.
Yeah.
I assume it's also easy to automatically uninstall worker.
Yes, you can. You can do the skip waiting thing. I don't know if there is. There probably is.
It's a problematic, obviously.
Yeah. Yeah, there probably is. I don't know it off the top of my head.
Another footgun is obviously, even if you do something like you listen for the install that there's a new version available and you prompt the user, there's a chance that they don't do it. And if you have a bug in your service worker, it's like, if you have a bug on your server, you fix it and it's fixed for all future requests, right? Like, but the service worker still lives and yeah. Yeah.
Do you know if there's like a time to where to solve the over aggressive caching problem, like for any caching body that's specified?
Well, I mean, you can specify that yourself, right? Yeah.
Probably. Yeah, probably.
Yeah, I think when you're writing it to the site.
Yeah, so like in a year, you just come back and look on the site.
So, yeah,
I
because
wonder why Meetup has no new data.
yeah, for example, the skip waiting thing, you can prompt the user, but you can actually choose to not even prompt the user and just do it. So that's possible to do. But of course, you have to have that logic in from the beginning. And if you never had that in, then you're basically there. You won't do anything.
The first time is very important.
Yes, like once you're in production, you better be sure that you have all those. Yeah. Yeah.
Versus 2
Okay, let me just refresh the page and see. Okay, cool. Yeah, so confirmed. The service worker cache was empty. We are offline. And now that we fetched again, the stuff is served from service worker, but I'm pretty sure it came from this cache. So which is kind of cool. Okay. Anyways, any other remix questions or service worker questions?
Basically, what are data service worker is like data that cannot be should not be deleted.
I actually think that the browser can delete it because I think if you overstore and you're running out of space, I think the browser is able to delete things from the cache. So I know, for example, in local storage, there is an API where you can do request persistent storage. And that basically flags to the browser that cache storage should not be deleted, even when you're running out of space. I want to say there probably is something similar to service worker caches as well. Again, not sure.
No, it's surprisingly.
And so, like, yeah, we can't do stuff like, partially cache, WebSocket data or something like that, but like, is there like some kind of good overall convention or like recommended approach to, for providing the user with the best experience offline, when it comes to, data that can just be, cached and some of that, data needs the connection? Is there some kind of?
Yeah, so I wouldn't say there's like a one best practice. There's, if you search like service worker caching strategies, there's a lot of strategies out there, right, that you can follow. Right, you can do like the whole always serve from the cache first, if there's something, or you can also do it where you always just fetch from the server if you're connected, and only serve from the cache if you're not connected. So there's like a lot of ways you can tackle this, and it's definitely custom to your site.
Yeah, I think it definitely mostly depends also on what kind of application you build. Like if you're building meetup.com, and I think the answer is just don't try to go offline, right? Like there's no value in your application to be offline because you depend on social data, right? But the second you have like something like a to-do app, maybe it makes sense to have everything offline first and only sync to the cloud to like sync between devices. But maybe then you only want to use the service worker to fetch all the JavaScript and stuff and have it always updated, the latest version of all the pages client side, right? So you don't even have to talk to the server at all.
And so that was also caching pictures and big files too.
Yes.
And so is there like a way to like maybe filter like some of those things that, yeah, so instead of like loading like 2 megabyte file, it's kind of like load some placeholder SVG that's like smaller or something?
Yes, you can definitely do that. So we didn't do that in here in our minimal example, but when a fetch request comes in, you can check what that request is, right? You can check whether or not it's for an image, like whether it's like being served from like binary or something. And another thing you can even do, like for example, another filter we didn't do, which it's probably something you should do, is check whether or not it's actually even a GET request, right? Because right now it's intercepting every single request. So if we do a POST request, it's catching that too. So and a production service worker, we probably want to also filter out the method as well. But yeah, you can do whatever filtering you want. And that's also, again, up to you and your app.
Any concern or like any complications here around password and custom stuff? Is Graph with like forward or whatever else? Where it's like do whatever you want, it's all in your hands.
Since everything is still on the client and you're basically just forwarding, you have the same limitations as with your normal fetch request, I would say. Anything that could be done in the browser can also be done, not like from a fetch perspective, right? Can also be done in service worker. We ran into one funny bug where it was like complaining that we tried to cache Chrome extensions. So we had to check for like, this is a Chrome extension, don't cache it. So like literally everything goes through here, it's fun.
And so then if that's the case, how, I guess you're just gonna have to, you will no matter what to do filtering because you don't know what the user has. Yes, right. You don't want to store.
Oh no, everything that goes, like everything that the browser fetches from your domain to show your page, or every fetch request that the programmer of that page made in that JavaScript goes through the service worker. So if they have if I have a second tab open here for my presentation, that doesn't go through the service worker, right? It's only stuff tied to this domain here. Yeah.
Domain is loading a Chrome extension, then it's getting.
Yes, so if you're on this page, right, then my Chrome extensions try to interact with this page. So apparently that goes through the service worker, which I thought was curious. Yeah. Yeah, I think the security model of service workers is pretty good. Like there's no concerns. Like I couldn't think about anything like off my head. Yeah. Just as always, like
But it's
security.
more than so like the work, I can't like install aerosolic work requirements on that.
Exactly. Yeah. Yeah, you have to download the service worker from the domain then.
So that's why you have the register thing. The register can only happen from the.
And then if you have a service worker in a sub file, like if I have my service worker in /admin/, it can only access /admin and not like it's not gonna be affected by all the other features. Cool.
The